Hello and welcome back to the 2022 Practice Exam 3 MCQ review. This video I'm just going to be only doing question number 40 because I didn't like my explanation for it the last time. It was a little different. So in question 40 we're shown a wheel and it has three force vectors all of equal magnitude pointing out. We have one here, A, one here, B, one here, C, another one here, D. So it asks us to rank the magnitude of torque about the axle exerted by each force. So we want the magnitude of torque, so the absolute value. So the first thing we can do is we can rule out B, we can rule out C, because the formula for torque that we're giving is F times R times the sine of theta. These two, this is radius of separation. They have zero radius of separation here, that's why I have dot here. They have zero radius of separation, so B and C are equal to each other. Now we just need to rank A and D. A and D have the same amount of force and the same amount of radius, so now what we need to do is find their sine of theta. So if we just divide this into quadrants like this, 1, 2, 3, 4, then we just find that sine of theta for A, I'm going to write that as sine of theta, is equal to 90, theta is equal to 90 degrees. And then D, sine of theta, 90 degrees is equal to 1, and sine, I'm going to say phi, we have phi is equal to, in the diagram, it looks to be around 120 degrees, and sine of 120 is about 0.7. So we know that A is greater than D, so the torque exerted from A is greater than D. Torque A greater torque D greater than torque B equal to torque C. That's how we've solved this in physics 1 way. And the other way I'm going to solve this is the calculus 3, vector calculus, and the physics C way. They teach you how to solve it. So for torque is what we call a cross product between force and radius. So force times radius, a cross product. What we're going to do here is we're going to divide the force into its I, J, and K vectors, and the radius into its I, J, and K vectors. I is going to be our X, J is going to be our Y vector, and K is going to be our Z vector. So, for example, torque A would be equal to, let's say this is I, J, K, force -1, 0, 0, the radius 0, 1, 0. So we would just multiply these together. -1, 1 is equal to negative k. So our torque vector would be equal to negative k. And the way you solve a determinant like that, a rectangular determinant, is let's just use variables A, B, C, alpha, beta, and I'm just going to use phi because I like it better than omega. A, B, C, alpha, beta, phi. So first thing you do is you want to get your I, so it'd be B times theta minus C times beta, and this would give us our I vector. And negative J, our Y vector, is going to be A times theta, A times phi, minus c times alpha. And then we would have a positive k vector now. In this, we just do a times b minus b times alpha. Beta, my bad. So that's how you solve a torque product. Torque using a cross product. And then we add all those torques together. When we do this all, it would give us an answer around that the torque of torque of B and C are zeros. We need to do this. Torque of B would be equal to this is I, J, K, force would to be 1 in the positive direction, 0 that direction, 0. Radius. So radius we know it's 1, and we it's sine of 120 and 1 cosine of 120 for its x and y components, which if we just put that into the calculator, we're going to get that our y component is 0.8 and that our cosine is negative 0.5, but I'm going to make this positive since we want to go counterclockwise. So we get for I, our I vector 0, 0, 0, so that's not anything. For j vector 1 times 0, 0 times 0. So our k vector 0.8 minus 0. Okay. That's it. So that's how you solve torque the physics 1 way and the calculus way.